Okay, so in this video we'll be looking at translators, and in the next video we'll be developing it in IDEs. So you can see a diagram or a couple of images in front of you. We've got Python programming code, we've got some assembly language, and you'll notice it's further away from English. So we can still work out things like imp means input. It's not as obvious as the word print or input or else. And then finally we've got our machine code or binary code, which is the only language the CPU is able to understand. So before we start talking about translators, let's have a little look at the different types of languages and why we have those. So we'll start by talking about high-level languages. Now we like these because they are the closest to English language of any of the languages. So the source code is easier for us to write. The trade-off is because it's closer to our English language, it is harder, or it takes more work to translate it into machine code for the CPU to understand. So some examples of high-level languages include Python, which obviously we've done a lot of work in. And I know some of you have coded in other high-level languages like C++, might have done some database work using SQL, and many others. The other language that we can code our programs in are low-level languages. Now these are harder for us to code in, but they are easier for the computer to run because they are closer to machine code. They take less processing power. So an example is assembly language. I'll go back to that image on the first slide in a second. And also machine code itself is classed as a low-level language. So we can see on these images, it is going to be far easier for us to code in Python than it is to code in machine code or even assembly. Like I said before, we can probably work some of the commands out, but it's not as straightforward. So let's do a little bit of a comparison now. Why do we have different levels of languages? So high-level languages, like we've already said, for us humans, it's easier for us to read, to add to modify someone else's code. But the trade-off is that it's got to be translated into machine code, and that takes a lot more work than translating a low-level language. Another benefit is the same program in that language will work on many different machines. Okay, whereas with a low-level language, it's normally processor specific. So if you write a program for one type of processor, you wouldn't be able to use that on a different machine. And with high-level languages, we don't have much control of the CPU. So our programs will run slower. Weather will notice that difference is negligible sometimes, and it will use more memory. And this is the big advantage of low-level languages, because you've got more control over the hardware and exactly what memory locations you're using and that kind of thing. The programs do tend to run faster and use less memory. Okay, that's why we use them. Like we said earlier, low-level languages, particularly machine code, is difficult to code in, it's difficult to read, but then the benefit of that is there's less translation needed, particularly if you have coded in machine code, which I wouldn't recommend. So we now know what a high-level language is, we know what a low-level language is. What we need to look at is how, when we've coded our program, does that then get translated for the CPU to understand. Now that is the role of a piece of software called a translator. Now that piece of software, its role is literally to convert our code in whatever programming language it is into machine code. Because remember, the CPU only understands machine code. Okay, or binary as we sometimes describe it. Different translators you will need to know about. If you are writing in a low-level language, particularly assembly language, you would use an assembler. That's the type of translator that we use for assembly language. However, if you're coding in a high-level language like Java, Python, any of those, you would either use a compiler or an interpreter. Now, both of those translators translate high-level code into machine code. So now we're going to have a little look at why there are two different types of translators for high-level language. So they do things differently. Okay, a compiler will translate all your code at once and it will create an executable file. So you only need to translate your code once, and then after that, because you've got an executable file, you just double click on that and run your program. So if we jump to point 4, it does take longer to translate your code into machine code using a compiler, but because it creates this executable file, the finished program will run more quickly every time you want to use it. Okay, now it's not always ideal for beginners because when you are translating your program, it will translate the whole thing and then give you a list of errors at the end. Now, we are used to an interpreter when we've been coding in Python. And what that does is, say you had an error on line 3, it would get to line 3 and it would stop. Okay, so you would then fix that and then you would carry on. So for beginners, it's much more useful because you're dealing with one error at a time. And if one of your errors earlier on is causing lots of the errors later in the program, if you fix that, then obviously it will stop the others. Okay, so compilers translates everything at once to create an executable file. Languages that use that, Java and C++. Now, we are more familiar with interpreters. We've been coding in Python idle through your GCSE, and we know that it translates the code line by line. So every time you load that program up and run it, it translates each line into machine code. Now, like we said, this is good for us because it helps us find errors and fix them at specific points. But the trade-off for that ease in debugging is that you can't create an executable file with an interpreter. So you need to load your code up every time you want to use it and run that program. Now, what that means is the program will run more slowly because that code needs to be translated every time you run the program. Okay, whereas if we go back to a compiler, the code is only translated once and then the executable file is created. Examples of languages that use interpreters are Python and JavaScript. I'm going to stop talking now. Please review the material, make sure you're happy with it all.